The role of the ATP in resynth is this. ATP is endothelin triphosphate that has three phosphates attached to it with bonds of chemical energy. It's only energy which can only allow for muscles to contract and locate at the ends of the myosin arms. For any contraction to take place, the bonds of the chemical energy will have to break apart from the phosphates, which then use the phosphate that has been broken off as our energy. It's a molecule which can carry energy because we need the energy extremely quickly. The process continues so the ATP is available for the contractions to take place. The slide of filament theory is where the muscle contraction takes place. So the myosin filaments and the actins can slide over each other so they can be shorten the length of the muscle fibers. This means that the bridge between the actin and myosin can form, which then use the ATP as an energy source. The resynthetic part of the ATP is vital, as the store of the ATP is very little and is used very quickly, normally within 3 seconds. It depends on what we need them for, as if we are lifting heavy weights, this will use all the ATP with very little ATPC anaerobic. This means that the phosphate that broken off by the bonds needs to get a new one so the muscles can continue to contract quickly and powerfully. The location of the ATP is at the muscles so we can use them quickly, and the liver, however, it is produced in the mitochondria. There are three phosphates and endothelin which are linked together by high energy bonds. The intensity of it is extremely hard and fast, as they contract very quickly. It takes around 3 minutes for our muscles to fully recover to the maximum store of ATP once the struggle to recover, which is normally about 3 minutes after the ATPC will take over. Phosphate creatine. This is stored within the muscle cells and is used to resynthesize the ATP and has high potential energy store. Has a high stores of potential energy. It works without oxygen and doesn't produce any waste products. It gives us energy extremely quickly but lasts for a short amount of time, usually around 10 seconds long. It breaks down the bonds, which then releases the energy joins onto the ADP, which then frees the phosphate so it forms the ATP. This is normally used in professional athletes 100 spin or any activity which lasts around or less than 10 seconds. The intensity of it is very fast and immediate, however not quite as fast as it lasts around 10 seconds, unlike the ATP which lasts around 3 seconds. The fuel from the ATP is the carbohydrate and fat. It doesn't produce any waste products. It lasts 3 minutes for the it takes at least 3 minutes for the ATP system to fully recover. It is complex as it has to break apart from ATP and then resynthesize. The advantage of it is that it's great for explosive use over the time and length of around 10 seconds, however it takes a while to recover from. Lactic acid system uses glycolysis to produce the ATP. It is used when the ATP and P stores have run out and we need more energy so this is provided by the lactic acid system. It breaks down the glucose in the muscles, which is stored by the glycogen. It doesn't use oxygen as this would take too long and is very complicated, which takes time. When it breaks down, the glucose provides the energy for the ADP to reform to the ATP. The system is used for around 10 seconds to 3 minutes. The intensity of it is very high and it would be used on a 400-meter race. Once a performer has stopped doing the activity, the oxygen which is broken has been inhaled, diffuses into the muscles and removes the lactic acid. It has found themselves and the fuel for the lactic acid system in the carbohydrate. It is found within themselves and the fuel for the lactic acid It's found within the muscles themselves, and the fuel from the lactic acid system is the carbohydrate which is broken down to give them energy. The lactic acid system recovery time is around 8 minutes, however can be improved with training to delay the time that the lactic acid system kicks in. It's not complex and it's not that complex as it doesn't use oxygen, however it does produce a product of carbon dioxide, which has to be removed. The advantage of this is that it can give energy fairly quickly without oxygen, however, can cause serious discomfort and pain over a prolonged period of time. Investigation data analysis. Blood lactate is produced by muscles, red blood cell, and red blood cells. When the aerobic system is used, the fast lytic fibers has been used, the lactic acid system quickly dissociates and releases the hydrogen ions. When the athlete is performing low intensity, the lactate will stay very low as the brain will tell the body to use the other systems available, such as the aerobic system. However, when it increases, the lactate will start to rise. This is evident in both of these tests, as they both have high amount of lactate by the end of them. This is shown as the lactate accumulation, which is the increased production of hydrogen ions. During the ATPP system, in the multi-fitness test, the lactic acid during level 4 is still very low due to the fact that the athlete is using the fast glycolytic fibers and the aerobic system are being used with no strain, so the athlete doesn't need any other system to help them out at a slow pace. At level 4, it was 4 millimoles of mercury, which is still very low. However, by the end, it reached 24 in the multi-fitness test, which shows by the end of the athlete was using huge amounts of lactic acid system. Even with the Wingate only lasting 20 seconds, the lactic acid system still gets heavily used, with it reaching 7.5 millimeters of mercury. Thwarting application analysis. ATP in football must be resynthesized once it's done the explosive movement and the fibers have been contracted. The function of the ATP is to provide the muscles with the energy so they can function and perform during the activity. The ATP pulls back the myosin head when it binds to the myosin. The function of the ATP is to provide the muscles with energy so they can function and perform during activity. The ATP pulls back the myosin head when it binds to the myosin head. The cross bridge between the actin and myosin will break away. The ATP also breaks away, causing ATPase, which makes the bond split and release a phosphate ion. This then can be used for intense energy over a period of time, or around 3 seconds. An example of this is when a thrower would use your ATP system, as this takes less than 3 seconds to do, and its wires are stored in the muscle cells, so this can be used straight away. Phosphocreatine, which is stored in the muscle cells as well. It provides energy by releasing phosphate. It lasts around 7 seconds in intense activity. The phosphocreatine is broken by an enzyme which creates the creatine and phosphate. When the phosphate creatine is broken down, it allows the energy to be used, and it takes around 2 minutes for it to recover and to be used again. An example of this would be a quick jog near to a ball and which would last under 7 seconds. The aerobic glycolytic system is used when the intensity is too much for the aerobic system and too long for the fast glycolytic system. It produces a lot of fuel for the muscles over a longer time than the fast glycolytic. The ATP stores glycogen, which then turns into energy by using the glucose. This is then broken down into lactate dehydrogenases in a net gain of 3 ATP to contraction for the contraction to take place. Once it breaks down further, it produces hydrogen ions. An example of this would be running up the pitch to receive a long ball from a defender to an attacker.